Radians versus degrees. What's the difference? And can't I just keep converting my radians into degrees since I already know how to use degrees? I bet that is the question that goes through every student's mind when learning about radians. But we're going to get speed on your side and let you be super, super familiar with radians so it's quick and you don't have to think much. Download the handout and you can follow along with me in this video. Hi, my name's Danielle and I'm a high school math teacher for over 18 years. And here on this channel, I love to share math strategies so learning math is made easier for you. Plus, I love sharing math videos so that way when you're outside of class, you have some support if you get stuck. So if you are a math student, definitely hit and subscribe to this channel so that way you can get notified when my latest videos are released. So radians are just another unit of measure, and it's like comparing the imperial system to the metric system. We could measure things in inches or we could measure them in centimeters. Radians really comes in handy when dealing with physics and engineering studies. So in order to not cause our brain too much strain, we are going to find a way to work with radians and just know what we're dealing with without having to always convert, because that takes time. We don't need to waste our mind time with conversion. So let's go over how to convert. We're going to start with going over how to convert from radians to degrees. If we needed to know what pi over 2 is here in degrees, we would times this by 180 divided by pi. And the pi's would cancel out and the 180 over 2 would convert to 90 degrees. If we wanted to do the same thing with pi, we would multiply by 180 over pi. The pi's would cancel out and we would just get 180 degrees. I'm picking these specific radians to convert because I want to place them on the Cartesian plane for us. Okay, so let's keep going. We have 3 pi over 2 times 180 divided by pi. If we cross this out, we are going to get 3 times 180 divided by 2, and that's going to reduce to 270 degrees. 2 pi, maybe some of you have already seen this. If we divide this, or multiply it, I should say, by 180 over pi, the pi's will cancel out and we'll get 360 degrees. So if you think about a circle, you start at 0 degrees, you go 90 degrees, then you go rotate 180 degrees. And then if I scooch down a little bit, we get 3 pi over 2, which is 270 degrees, and back to the full circle, 360 or 2 pi. Okay, so now we're going to be looking at our circle of rotation in radians. The first thing I want to do is I want to take this circle, or actually, let's even do half a circle, semicircle, and I would really like to look at, I'm going to try and do this with a line here. Inserting shapes. Let's do a line. I would really like to divvy up the top half of this Cartesian plane into 3 equal parts. So if you follow along with me, get you down here and let's rotate you. You can see with my ruler, okay, and hopefully you guys are able, to do this with your ruler. You're going to place these arrows. I'm just going to extend this a little bit and rotate it a bit more so it's a little straight because it drives me crazy when it's not. Okay, so let's see. Does that work? Yeah, that's a little better. Okay, so if you can see in the top half, we have 3 equal parts. So 1, 2, and 3. The way I would like for us to look at this is literally in sections of 3s. We're going to use fractions right now. So if I rotate 1/3 of the way, I'm going 1/3 of the way, but I'm just going to put pi thirds of the way. If I go another third of the way, I'm going 2 pi thirds of the way. And then if I go another third of the way, I'm going 3 pi thirds of the way. 3 over 3 is just 1. So it equals pi. We can keep doing this on the bottom. So if we extend these lines and divvy up the bottom half into 3 sections, you will go, so 3 pies of the way, you will go 4 pi thirds of the way. Sorry, over here, 5 pi thirds of the way. And then over here, 6 pi thirds of the way, which is just reduced to 2 pi. So you can see, like, just thinking logically about fractions, this is 1/3 of the way, 2/3 of the way, 3/3 of the way, 4/3 of the way, 5/3 of the way, and 6/3 of the way. I always think of 2 pi in terms of the denominator I'm working with. So if I asked you to locate 5 pi over 3, I know this is going to be 6 pi over 3 to get it equal to 2 pi because I want the denominator to be 3. And this is going to be 3 pi over 3 because I want this to be 1 whole. Okay. If for some reason the fraction was over 7, this would have to be 14 pi over 7 because that's what's going to give me 2 pi. And this would be 7 pi over 7. Okay. And I would have to divvy this up into 7 equal sections. So I'm going to take those away because we don't actually work with the denominator 7 when we're talking about special triangles. And this is what we're doing here is to help us work with special triangles and cast rule. But, and let me get rid of that 7 as well. If I were to ask you now, where is 5 pi over 3? You would think, okay, this is 3 over 3. This is 6 over 3. So then 4 over 3 would be here and 5 over 3 would be here. It has to be in quadrant 4. And that's the goal. We want to be able to locate the quadrant this radian is in without thinking about degrees anymore. Okay, so now if we look at this Cartesian plane, it's being divided into 4 equal sections. So we are going 1/4 of the way, 2/4 of the way, 3/4 of the way, and 4/4 of the way. So here I can say that this is 0, but then if we rotate it up, we're going 1/4 of the way, but I'm going to put pi over 4. Then here it's going to be 2/4 of the way or 2 pi over 4, which just reduces to a half or pi over 2. Then here we're going to go 3/4 of the way, 3 pi over 4. And then here would be 4 pi over 4, which also equals pi. Let's divvy up the bottom half in the same equal parts. So here we have 1, 2, and 3. Not as equal as the top half, but you know what I'm trying to get at. So here, if I rotate from 4/4, I'm going to 5/4. So there's another quarter. If I add another quarter off of that, I'm going to go to 6/4. So 6 pi over 4, which is equal to 3 pi over 2. If I add a quarter to that, I'm going to go to 7 pi over 4. And another quarter after that, I'm going to get to 8 pi over 4, which is just 2 pi when reduced. So now if I said to you, okay, where is 3 pi over 4? You're going to think, okay, this is 0, but if I go all the way to here, it's 4 over 4. 3 over 4 is just 1 away from it. So it has to be lying in quadrant 2. All right, let's try now divvying it up. I know this looks a little more chaotic, but we love chaos, right? Because we're going to take what we learned and just apply it. We're going to divvy this up into 6 equal parts because the other denominator you're going to see in special triangles is over 6 with radians. So 1/6 of the way, so let's call this pi over 6. 2/6 of the way, which we know is equal to just, pi over 3. Then we go 3/6 of the way, and 3/6 of the way is just pi over 2. 4/6 of the way, 4/6 is also just 2 pi by 3. And then another part is going to be, or another 1/6 of the way is going to be 5 over 6 or 5 pi by 6. And another 6 is going to be 6 pi by 6, which is, of course, pi. Let's keep going. 7 pi over 6, 8 pi over 6, which is just going to reduce to 4 pi over 3. This is going to be 9 pi over 6, which of course, can't see my little 6. 9 pi over 6, which is going to reduce to 3 pi over 2. This is going to be 10 pi over 6, which we can reduce that to 5 pi over 3. And then 11 pi by 6. And of course, the last one, 12 pi by 6. I know you're feeling this, right? You're getting into the radian flow. So what does this mean? This means now when we ask you to locate where is 7 pi over 6, you're not going to think anymore, I need to convert to degrees. No, all you're going to do is say, hey, 6 over 6 is here. 12 over 6 is here. So 7 over 6 is one more than this. So it has to be quadrant 3. Now, something interesting I'm going to highlight is we've already located some of these in the first circle we worked with. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, if we scroll back up, are the original fractions we first started with. So they just sit in the same spot in this circle as they did in the one up above. So they're just an overlap of angles, okay? Because these ended up reducing to what we already discovered. Okay, so now it's time for us to practice. If I asked you to close your eyes and locate 7 pi over 4, what you're doing is saying, okay, this is going to be 4 over 4, and this is going to be 8 pi over 4. And if you wanted, you could say 2 pi over 4 over here, okay? And 7 pi over 4, 7 pi over 4, 7 is really close to 8. It's right here. So you're going to say, I'm in quadrant 4. If I asked you to rotate a negative angle, negative angles start on the positive x-axis and go clockwise. You're just going to do the same thing, okay? So now this time is 0. This is negative pi over 2. This is negative pi, and this is negative 3 pi over 2. So when you think about 3 over 3 or negative 3 pi over 3, it's going to be sitting here, and this is going to be negative 2 pi. So where's negative 2 pi over 3? This is going to be negative pi over 3. This is going to be negative 2 pi over 3 here. Okay, so it's going to be in quadrant, what is that? 3. 5 pi by 6. Okay, hit pause and try this one on your own. Did you get it? Let's see. So this is 6 pi over 6, and this is 12 pi over 6. So then 5 pi over 6 has to be in quadrant 1 because it's one less than this. I hope you enjoyed that. And there you have it. You are now a Radian Pro. No more turning to your calculator to change back to degrees. You can totally do this right up here. I hope you enjoyed the video. If you have any questions, let me know in the comments below, and definitely hit subscribe so you can be notified when the next video is ready. Bye.